So here we are discussing about trapezium. Basically, trapezium is a quadrilateral. We have already discussed about squares and rectangles, where square being a figure like this, where we have all the vertices, all the edges at the right angle. Square also has the same property for rectangle. The main difference comes in where in square we all the edges are of equal length, whereas in rectangle we have opposite edges are of equal length. Okay, and area of square we find if I have side A, it would be A square. If I have a length L and B and breadth B, then area of my rectangle would be L into B, L cross B. So I can easily find my square if I have given any of the sides, and I can find my area of rectangle if length as well as breadth is given to me. So let us we have already understood this concept in our previous lectures. So here we would be learning about some properties of the trapezium and how do we determine area for trapezium. So let's see what the trapezium figure looks like. It is basically quadrilateral, where you would find two parallel edges. Let a parallel edge be A, let another be B. The A and B parallel edges are parallel to each other, having a perpendicular distance separation of h. Okay, here h is my perpendicular distance from A and B. I could also have my distance like this. Let me call it as L, where L is my slant length, but I won't be considering my slant length because I will only require my vertical distance, which is my perpendicular distance between the two parallel edges, and not my slant distance between the two edges. I will be considering only my perpendicular distance while calculating area. Let's see how. Okay, clear? Understood here till here? If you have any issues, you may raise it at any point of time. I would definitely try to resolve it. Okay, so let's just quickly check these. How do we determine area for trapezium? See, area of trapezium is determined as half times the sum of the parallel edges, the sum of the two opposite parallel edges, here being A plus B, okay, and times my this perpendicular distance between the two edges, h. Note, a point to be noted here is, let me change my pen. You got it till here? Okay, I'm sure you got. See, either of A or B, either of A or B must be what? Must be smaller. Or can say that my A and B must not be equal. My A and B must not be equal. Why would I say it? Because if it become equal, let's suppose the condition like this, I would get my rectangle. I won't get my trapezium like figure. Okay, seems clear now? So in rectangle, basically what do we have? We have two parallel sets of edges. If I have A, B, C, D, I can say AB is parallel with CD while my BC is again parallel with AD. Seems clear? But if I just have a shorter length of AD as compared to my BC, if I just reduce it to some extent, and let me draw the quadrilateral again, I would have something like this, and this is where our concept of trapezium comes. Seems clear? So this figure is my trapezium, and this is the formula for determining the area. Okay, let's quickly check up a question, after which I will be assigning a question to you, then you should try. Clear enough? Okay, so let's move further. Let me assign a question. I have a question given trapezium with shorter and longer edges B and 10 centimeter respectively, where the distance of separation between two given edges be what? Let's suppose 12 centimeter. Then it is said find the area of trapezium. Okay, it's a direct one. Let me just solve it. Let me just illustrate it, how we plug in the values in our formula. After that, I will give you an interesting question for you to try. Okay, so let's just quickly set our pen, and here we definitely apply our formula which we have learned, which we have just deduced. Area of trapezium. See, let's make it more interesting. Let's draw the trapezium and visualize the edges, visualize the question more clearly. So let me mark A, B, C and D, where my AD length, it's given that my shorter edge is 8 centimeter, where my longer parallel edge, I should write, okay, you must know that we would be giving parallel edges only. So my longer edge is about 10 centimeter. Clear enough? I have this parallel. See, A and B and C and D are not parallel. They must not be parallel to call this ABCD figure to be trapezium. Otherwise, it would be a parallelogram or a rectangle like figure. Okay, just keep this in mind. The AD or BC, one of these lengths must be shorter than the other. Then only we will get trapezium. Seems clear? Okay, let's move further in our question. What's given next? And it is given where the perpendicular distance of the separation between the two given edges. See, I have two given edges AD and BC. I have two edges AD and BC. I have perpendicular distance separation. Separation is the distance between them, and I have perpendicular separation. So I will be dropping a perpendicular. This perpendicular separation is given to me what? It is 12 centimeter. So I think I have all the stuff required for finding area. So my area would be half times summation of my parallel edges times the distance of the separation, perpendicular distance of the separation. So a plus b would be my 8 plus 10 times 12. Just simplifying, I would get 6 here. Can you tell me? Can you guess? What should I write here? Yeah, what should I write? Can you just speak up? Yeah, it would be 18 times 6. Next, what should be the answer? Go ahead. 18 times 6 is what? 108? Yeah, 108. And since it is in centimeter, area would be in centimeter square. Okay, so this is my answer. So this is how we find the area of trapezium. Let's check another one. This question you must be solving. Okay, I have given with table of the form trapezium. I have given with the table, like suppose I have a table like this. Let me draw table with 4 legs. It may be dining table or something like that. So I have a trapezium shape of the table where it's given shorter parallel edge length to be 1.8 meters and my longer parallel edge length is given to me 2.4 meters, where the perpendicular distance between two parallel edges B, suppose is 1.6 meters. Then determine. Yeah, you may just try to solve. Yeah, you can start solving. Determine the area, the figure. Okay, my figure is, you have to find the area of this complete shaded region. You may just solve. And just tell me what you are getting as your answer. I will just cross check your answer. Okay, so you have to determine the area of this complete figure, which is in trapezium form. Okay, I'm just solving it here. You may just check after you have done with. Let's now see. I'm solving here. You may just check. Are you getting anything? Okay, let me just check whether you are getting right. I would be 8 or 1.8. It would be what, 4.6? 4.6 no, or 3.6? I think it's 4. I think it's 4.2. 4.2 times 0.8. Yeah, so you were getting, I think so you are just telling the same answer. Yeah, you're right. So this is how we find the area of trapezium. Seems clear? You may just solve further questions, more about the questions as given in your assignment. Okay, so let us now move about the next quadrilateral, which is our rhombus. Let's move towards rhombus. Okay, herein first property of rhombus is all sides are equal, first of all. Okay, second point is my all sides are equal, and opposite sides are parallel. Let me draw. Okay, I would be having something like this. Clear? Wherein if I have a, let me draw, if A, B, C, D, if my side let's suppose CD is given to me 7 centimeter, then I would assign 7 centimeter to all of my sides. Clear? Seems clear? Because all sides are of equal length, and what I can say, if AB is parallel to CD, then my AD would be parallel to BC. Opposite sides are parallel. So these are basic two properties. What did you say? Can you just repeat? No. Wait. Yeah, it's a very good question. You said why rhombus may not be a square since all sides are equal. But see, I have said all sides must be equal. That's correct. That's one aspect. Another aspect must also be same, wherein all sides must be parallel. Okay. In square, we also have opposite sides are parallel. Okay. Yeah. So what may be another exception point about the rhombus and the square, which is a differentiating factor between them? If I also have a square of ABCD, I still have my AD parallel with BC. Likewise we have in this rhombus, as well as have my AB parallel to CD. Similarly, I have here also. So all sides are also equal. So what's the differentiating factor? The differentiating factor is that in my square I have all my angle between the two adjacent edges are of right angle, 90 degree, whereas in my rhombus one is my greater than 90 degree and another being acute. Okay, the complementary angles, this would be angle greater than 90 degree. This is less than 90 degree. It is greater than 90 degree. Here it is less than 90 degree. Seems clear? So this is my only difference between rhombus and square. Yeah, they are they are much of like brothers, but we have different properties, as well as we would have different area. Let us suppose, if I tell you how to determine area of rhombus, you would be like, as we did of area of the square, what was it? If I side of my square is a, area of my rhombus, you would be like a square. No, but it's not the case for rhombus. It's not a square. Let's draw rhombus again. If I have a rhombus like this, A, B, C, D. Can you just tell me what I am drawing here? If I just connect BD and AC, what I can say BD and CA2? What are these? What are these? Can you just guess? What are these? Can you just figure it out? Yes. They are my diagonals. Okay. You've got it. So area of rhombus is determined as, let me call BD diagonal as D1 and AC diagonal will be D2. Okay. So I would be determining area of rhombus as D1 times D2. Simple, not D1 times D2. I would just divide the product by 2. And this is my final area of rhombus, which I would be using for solving my numericals. Seems clear? Any issues till now? You may just pinpoint at any point of time. I would be just explaining the whole concept for me by using different illustrations. If you are not getting, using the provided illustration. Okay, so feel free to ask. So this is the formula. You should learn this formula now itself, after which we will be solving some of the questions based on the rhombus. Okay, so let's now move towards an illustration. Let's suppose illustration. After that I will assign 1 or 2 questions on rhombus. Let us suppose I have given with the rhombus with area A, okay, and diagonals of which are also given to me as D1 and D2 be 8 centimeter and 12 centimeter. Okay, it is said that find A. So I given with the statement, given rhombus area with A, diagonals of which are D1 and D2 having their values 8 centimeter, 12 centimeter respectively, find A. So we have just now saw the formula for area of diagonal, area of rhombus. So we will be just multiplying, just taking the cross with the diagonals and just divide the product by 2. So I will be having 8 times 12 divided by 2. Let me just cancel. So I would be getting 8 sixza. 8 sixza is my what? 48. 48, which SI unit I will be having? Centimeter squared. This is my answer. Seems clear? So this is my value of A, which I was needed to find. So area of rhombus is pretty much simple. You don't have to remember any of the things. Okay, you just remember these basic concepts, then you will be solving any of the questions. So okay, let me give you a question for solving you. Let us suppose Let me give you a question on rhombus. So you have to find the diagonal of a rhombus having area 132 centimeter square with another diagonal of the measure to be what, 12 centimeter. So you may just attempt and just provide the answer. I would just check here for you. So you may just start. Let me just cross check. I am solving. Start solving. You solve yourself. Just check it here after you are done. Are you getting anything? What to get? Okay, let me just check. I have to determine D2. Okay, determine D2. So let's plug in all the values in our formula. Let D2 be D2 itself. 2 here. Let me cancel 12 with 2. I would be having 6. I would be having 132 is equals to 6 times D1. So divide equation by 6. We would be getting 132 divided by 6. 6 into D1 divided by 6. So after dividing the equation 6, I can easily cancel out my 6, and I would be having 132 divided by 6 as D1, which is needed to find. So can you just solve? Can you just tell me what you are getting? Yeah, it's 22 centimeters. So my other diagonal is of the measure 22 centimeters. So this is how you occupy the usage of area of rhombus for solving problems. Okay. So let's stop here. We would be moving to our next sets of aspect for our mensuration concept in our next lectures. Thank you.